In this lecture, we're going to be learning about tides, what causes tides to change in the oceans. So the definition of a tide is the periodic rise and fall of sea level within a day. And depending on where you are in the planet, that may happen once a day, it may happen twice a day. In the San Francisco Bay, it happens twice a day. Tides are measured relative to points on land. The highest level is known as high tide, thus the lowest level is known as low tide. Pretty straightforward. Tidal ranges are the difference in feet or meters between a high tide and the next low tide. Tidal ranges vary due to topography as well as latitude, and I'll explain why. So, examples. A low range, meaning that there's not a huge difference between the high tide and the low tide, is in the Gulf of Mexico, where the tidal range is only about a meter. A high range is in the Bay of Fundy, which is between New Brunswick and Nova Scotia, way up north by Canada on the east coast. The tidal range there can be as much as 15 meters. What causes the tides, though? Well, gravitational forces. Gravitational forces cause the Earth and the Moon to be pulled towards one another. The liquid on the side of the Earth that is closest to the Moon is pulled toward the Moon, which produces a bulge. So here we have the Moon and we have the Earth, and these bulges are representing Earth's oceans. So the gravitational pull from the Moon is actually what is causing a slight pull on the Earth. And as the Earth is pulled, it's actually creating bulges in the oceans. I'll explain more about it as we go through this. The center of the Earth is also pulled towards the Moon. Thus, the water on the opposite of the Earth is left behind, causing a bulge on the opposite side. So, here's the Moon, and its gravitational pull is affecting the ocean on this side of the Earth. So we see this bulge here because the oceans here are being pulled by the Moon's gravitational effects. The center of the Earth is also being pulled, though, and that leaves behind the water that is on the opposite side. So we end up with a bulge on either side of the Earth. And what that produces is 2 high tides and 2 low tides. Because there are 2 bulges, a point on Earth experiences 2 high tides and 2 low tides in one day. So this is a representation of change in water level at one point on Earth over a 24-hour period. And what you can see are 2 high tides, high tide, and then 2 low tides. So there are 2 high tides and 2 low tides in one 24-hour period. All right, so let's talk about tidal cycles. The Moon rotates around the Earth at a rate of 13.2 degrees per day, so about 1 revolution per month. The rotation is in the same direction as the Earth spins. So don't forget, the Earth not only orbits around the Sun, as it's orbiting around the Sun, it is also rotating on its axes. So as the Moon is orbiting around the Earth is rotating on its axes, and both of those are happening in the same direction. By the time the Earth has completed one rotation, the Moon has shifted 13.2 degrees in its 360-degree orbit around Earth. So the Earth completes a rotation in 24 hours, hence the reason we have night and day. Within that 24 hours, the Moon has shifted 13.2 degrees in relation to its position with the Earth. So it takes an Earth-based observer an extra 50 minutes to be in a point where the Moon is at about the same position overhead. this can sound a little overwhelming. So think of it this way. You have two people who are running on a track. They start at the same location. They run at exactly the same pace. Who's going to finish first? Well, the person on the inside of the track, of course, because they're covering slightly less distance. Well, that's the same idea as is happening with the Earth and the Moon. So a tidal cycle is actually 24 hours and 50 minutes. It takes the Moon about 50 minutes to catch up with the rotation of Earth. So high and low tides are 50 minutes later every day. So let's take a look at what this looks like. These are two images of the crescent moon, Venus, and Jupiter, as seen in Quebec and as seen in Los Angeles. These pictures were taken at about the same time of evening, but the lower picture, which is taken 3 time zones to the west, was taken nearly 3 hours later, so the moon's position has been shifted to the left as a result of its orbital motion during that period. So we can actually see the moon moving. So they were taken at about the same time at night. Let's say this was 9 o'clock at night. But 9 o'clock at night in Los Angeles is actually midnight in Quebec. And you can see that within that time period, the moon has actually shifted. So here's Venus up here. Here's the moon. Here's Jupiter. Here's the moon. Here's Venus. And here's Jupiter. So it is the same position in the night sky, but the moon has actually shifted because it is orbiting around the Earth in the same direction that the Earth is spinning. This is what causes our tides to be 50 minutes later each day, because it takes an Earth-based observer about 50 minutes to catch up. Alright, the sun also has an effect on tides. The moon has a greater effect because it's much closer to us, although the moon is much smaller than the sun. And in actuality, the size of the sun would make it possible for the sun to have more of a gravitational effect than the moon, just based on size. But the moon is so much closer that it ends up having more of a gravitational effect than the sun does. So the sun exerts a gravitational force that's 180 times stronger than the moon because of its size. But the gravitational attraction decreases as the distance between bodies increases. The sun's influence on tides is much smaller than the influence of the moon for this reason. So the sun's pull can either heighten the moon's effect or counteract them depending on where the moon is in relation to the sun. Let's talk about what that means. Alright, so there are two types of tides because of this sun-moon relationship. The first type of tide is what is known as a spring tide. When the sun, moon, and earth are aligned, the sun's gravitational pull actually heightens the effect of the moon. That's what we see here in this image. The sun, the moon, and the earth are all in line. So this gravitational effect of the moon on the tides is enhanced because the sun is in line with it. So higher tides are higher and lower tides are lower. So there's a larger tidal range. And these tides are what we call spring tides. Spring tides occur at a full moon and a new moon. So new moon is when we see the moon as being mostly dark, and full moon is when it's at its brightest because it's reflecting the light from the sun. Now, the other type of effect is what is known as a neap tide. This is when the sun's gravitational pull is perpendicular to that of the moon, thus the sun is counteracting the effect of the moon. The sun is pulling water away from the areas of high tide, so the moon is still having a larger gravitational effect, so it is the moon that is still determining our high and our low tides, but the high tides aren't going to be as high and the low tides aren't going to be as low because the sun is still exerting some gravitational effect. So it results in a smaller tidal range. This occurs when the moon is in its first quarter and also its last quarter. So this is when you're seeing either a quarter of the moon. Okay, and that's exactly what we're seeing here. This is a springtide, and you can see that the gravitational pull of the moon on the water has been heightened because of the gravitational effect from the sun. And in a neap tide, the high tide of the Earth has actually been, the high tide from the moon has actually been lessened because it's being counteracted by the sun. And that's tides. That's how tides are created, and that's why tides are 50 minutes later each day.